Hello children, welcome to calculus. Then today we discuss about the fundamental theorem of arithmetic. Fundamental theorem of arithmetic. Before going to that, let us revise some portions. Then what are prime numbers and composite numbers? You all know prime numbers and composite numbers. What is prime and what is composite? That is, a number which has only two factors is called prime number. It is a number which have only two factors is called prime number. Which are the two factors? 1 and the number itself. Then what is composite? That is a number which has more than two factors are called composite numbers. That is a number which has only two factors are called prime number, and a number which has more than two factors are called composite number. Then which is the smallest prime number? Yes, 2 is the smallest prime number. Then 1 is neither prime nor composite. Neither prime nor composite. Then in smaller classes we studied about that sieve of Eratosthenes, and then we find out the number of prime numbers from 1 to 100. That is 25, that we know. And then 1 is neither prime nor composite. Then 2 is the smallest prime number. So 2 can be written as 1 into 2. That is, the factors of 2 are 1 and 2. That is, it has only two factors. So this 2 is a prime number. Then what about 3? 3 can be written as 1 into 3. So the factors are 1 and 3. So 3 also a prime number. Then what about 4? 4 is equal to 1 into 4. Then it can be 2 into 2. So the factors are, what are 1, 2, 4. So more than two factors it has. So this 4 is a composite number. 2 and 3 are prime numbers. In that way we can find out, that is a number which has only two factors are called prime numbers, and numbers which have more than two factors are called composite number. In that way 2 is the smallest prime number and 4 is the smallest composite number. But 2 is even, except 2 all other even numbers are composite. While all the even numbers are multiples of 2. So 2 is a factor of that number. 1 and the number itself are factors. So 2 factors are there for every number. Then even numbers 2 also have a factor. So all the even numbers except 2 are composite numbers. 2 is the only even prime number. That also you know. So a number which have more than two factors are called composite number, and a number which has only two factors are called prime number. That two factors are 1 and the number itself. Let us take some example. Listen, 12. 12, we know that 1 into 12 is 12. Then 12 is an even number. So 2 is definitely a factor. So 2 into what? 2 into 6 is 12. Then 3 into 4 is 12. Then any other number? No. So the factors of 12 are 1, 12, 2, 6, 3, 4. That is 6 factors are there. So 12 is a composite number. Then what about divisibility test? You know the divisibility test, that also you studied in smaller classes. That is divisibility test of 2. If a number ends with 0, 2, 4, 6, 8, then it is divisible by 2. For example, a big number I write 4, 2, 3, 6, 8. This number is divisible by 2. Because the last digit is 8. So it is divisible by 2. Then 4, 2, 3, 6, 9. This is not divisible by 2. In that way we can find out. That is the unit place number. That is a number ends with 0, 2, 4, 6, 8. Then that will be divisible by 2. Then what about 3? Divisibility test. The sum of the digits is a multiple of 3. Sum of digits is a multiple of 3. Multiple of 3. For example, 4, 2, 5, 1, 7. Then sum of digits, that is 4 plus 2 plus 5 plus 1 plus 7. 4 plus 2, 6 plus 5, 11 plus 1, 12 plus 7, we get 19. But 19 is not divisible by 3. That is 3 table 19 is not there. So this number is not divisible by 3. Or if it is 4, 2, 5, 1, 6, then 4 plus 2 plus 5 plus 1 plus 6. 4 plus 2, 6 plus 5, 11 plus 1, 12 plus 6, 18. This 18, 3, 6 times 18. So, this 18 divided by 3, we get the remainder 0. That is, 3 is a factor of 18. So, this is the divisibility test of 3. That also we know. Then, divisibility test of 4. That is, the last 2 digits. Last 2 digits is divisible by 4. Is divisible by 4, then the whole number is divisible by 4. Let us take an example. 2, 6, 7, 8, 4, 8. The last 2 digit is 48. 48 divided by 4, we get 2 times 8, 0. The remainder 0. So, this 4 is a factor. And then divisibility test of 5. That is, the number ends with 0 or 5. That also we know. 5 table 0, 5, 0, 5, that number ends. So, if a number ends with 0 or 5, it is divisible by 5. What about the divisibility of 6? If a number is divisible by both 2 and 3, then it is divisible by 6. For example, 2, 4, 5, 6, 7. This number, the last digit is 7, so 2 is not divisible. That's why 6 also not divisible. If it is 2, 4, 5, 6, 8, the last digit is 8, so it is divisible by 2. Then we check if it is divisible by 3. Sum of the digits 2 plus 4, 6 plus 5, 11 plus 6, 17 plus 8, 25. This 25 again we can add 2 plus 5, 7. So 7 is not divisible by 3. So this whole number is not divisible by 6, because if a number is divisible by 6, it is divisible by both 2 and 3. Both 2 and 3 divisibility satisfies only that number is divisible by 6. Then divisibility of 7. Then I think that smaller classes you didn't study the divisibility of 7. For example, 4, 8, 5, 3, 6, 2. So, the number formed by last 3 digits is 362. The number formed by other digits is 485. Then take the difference, that is 485 minus 362. 5 minus 2, 3. 8 minus 6, 2. 4 minus 3, 1. So, then we check 123 is it divisible by 7. 1 times 7, subtracting 5. Then 3 bring down 53. How many times? 7 times 49. Then 4 is the remainder. Remainder is not equal to 0. So, this number is not divisible by 7, or 7 is not a factor of this number. So, that's why 7 is not a factor of this big number. That is, this big number is not divisible by 7. 7 divisibility you didn't study, so you remember, you take the number formed by the last 3 digits and the number formed by the rest of the digits. Then take the difference. If that difference is divisible by 7, the whole number is divisible by 7. Okay. The next divisibility of 8. That is the last 3 digits. Last 3 digits is divisible. Last 3 digits is divisible by 8. Then the whole number is divisible by 8. Let's just check. 4, 2, 8, 4, 3, 2. The last 3 digit is 432. Then we check if this 432 is divisible by 8. 8 table we take, then 8 5s are 40, 3 remainder, then 2 bring down 32, 8 4s are 32, remainder 0. So, 8 is a factor of 432. So, this whole number also divisible by 8. This is the divisibility test of 8. Then, divisibility of 9, that is sum of digits is a multiple of 9. Same like 3. Let us take an example. 432, 5, 6. Then sum 4 plus 3 is 7 plus 2 9 plus 5 14 plus 6 20. 20 is not divisible by 9. So this number is not divisible by 9. The divisibility of 10. Divisibility of 10, we all know that the number ends with 0. Number ends with 0, then the number is divisible by 10. Then divisibility of 11, that is we write the number and from right to left we count the numbers 1, 2, 3 etc. like that. Then odd places sum and even places sum we take and then take the difference. If that difference is 0 or a multiple of 11, the whole number is a multiple of 11. Okay, let us take an example. 4, 6, 8, 7, 3, 2. First we write this number, then from right to left we count the numbers 1, 2, 3, 4, 5, 6. This is odd place and this odd place, 5 is the odd place. Then odd places sum. Odd places sum, that equal to 5 plus 7 plus 2. That is first place 2, third place 7, fifth place 6. So we add this 5 plus 7 12 plus 2 14. Then we add even places sum. Even places sum. That is even places sum here 4 plus 8 plus 3. That is 6th place, 4th place and 2nd place. 4 plus 8 12 plus 3 15. Then we take the difference. Then we take the difference equal to 15 minus 14, that equal to 1. So this is not a multiple of 11 and it is not equal to 0. So this whole number is not divisible by 11. So if it is 0, if we get the difference is 0, it is divisible by 11. Or the multiple of 11, that is 22, 33, that way it also divisible by 11. Okay. Then we know prime factorization. Is it? Prime factorization. What is prime factorization? Prime factorization means factorize using prime numbers only. We know that the prime numbers are 2, then 3, then 5, then 7, then 9 is not a prime number, 9 is a composite number, that we know. Then 11, 13, that way, that is the prime numbers are 2, 3, 5, 7, 11, 13, etc. That way it is going. Then prime factorization means factorize only through prime numbers. That is, let us take an example 12. 12 we write in this way. Then first we take the smallest prime number. Then if it is not possible, then take the next prime number. That way, that order you use. That is 2. 2 when dividing 6. Again 2. 3. Then 3 is here. 2 is not a factor of 3. So we take 3 outside, then 1. So these are the factors. So 12 we can write 2 into 2 into 3. The next number 24. 24 we factorize 2, then 12, again 2, then 6, then 2, 3, then 3, 1. So 24 can be written as 2 into 2 into 2 into 3. Then 36. 36 we write 2, then it is, if it is an even number, then 2 is definitely a factor 2, then 18, then again 2, 9, then this is not even, so next 3, 3, then 3, 1. So this 36 can be written as 2 into 2 into 3 into 3. Is this 12 a composite or prime? 12 is a composite number and 2 and 3 are prime numbers. Here 24 is a composite number and 2 and 3 are prime numbers. Here 36 is a composite number, 2 and 3 are prime numbers. So from this we can say that every composite number can be expressed as the product of prime numbers, and this factorization is unique apart from the order in which the primes occur. That is fundamental theorem of arithmetic. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which prime factors occur. Order means first you take the smallest prime number, that is 2, and if 2 is not possible, then only you take 3. So fundamental theorem of arithmetic, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which prime factors occur. Fundamental theorem of arithmetic has many applications in mathematics and other fields also. Then consider a number 4 raised to n, where n is a natural number. Then for any n, then 4 raised to n, the digit with ending with a 0, it should be divisible by 5, that we know. That is, the prime factorization contains the number 5. But 4 raised to n can be written as 4 is 2 square, the whole raised to n. That is 2 raised to 2n. We know that in exponents a raised to m, the whole raised to n, that is equal to a raised to m into n. That way 2 raised to 2n. If we put n equal to 1, it is 2 square. If we put n equal to 2, it is 2 raised to 2 into 2, 4. That is, then n is equal to 3, that is 2 raised to 6. That way, that is any number, any natural number we put for n, that becomes 2 raised to that number. That is, the uniqueness of fundamental theorem says that there is no other primes other than 2. That is, there is no natural number n for which 4 raised to n ends with the digit 0. That is once more fundamental theorem of arithmetic. Every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which prime factors occur. So from here we wind up this class. If you like this video, please like, subscribe and share. Okay, thank you.